Now we'll go with the next group element, that is in 14th group elements or 4th A group element. 14th group elements or 4A group element. This group, it is consisting of different types of elements like carbon, silicon, germanium, tin and lead. Okay, so this as this first element of this one, it is called as in carbon. We can also consider it as in carbon family. Again here also, as the outermost orbit of this, outermost electron or differentiating electron, it is entering into the p orbital. So we are considering this carbon family, that is in 14th group family or 4th A family. It is considered as a p block elements. Okay, now in this case, as the first carbon I told you, that is in first element is in carbon, we can consider it as in carbon family. The general electronic configuration is ns2 and p2. Some of the peculiar properties of these elements in this group, that is, I told you that is in the organic chemistry, I told you the best peculiar property of the carbon family, that carbon, it is forming more than 3 millions of carbon compounds, right? It is forming more than 3 million carbon compounds. What is the reason for the formation of more than 3 million compounds in the case of carbon? So I told you that the reason is one is tetravalency, that is combining capacity of 4 with other elements or the same element, right? Another one, it is called catenation. Catenation means the self-combining capacity, right? Catenation means self-combining capacity. The self-combining capacity for this carbon, it is more in all considering when comparing with all the elements in the periodic table, the self-combining capacity, it is very more, and this combining capacity, it may be in the form of linear, or it may be in the form of branches, or it may be in the form of circle, or in the form of ring. So this is catenation capacity. This is a peculiar property in the case of carbon family, particularly for the carbon. After the carbon, the next catenation capacity in this group is silicon. Okay, silicon also, it is having the self-combining capacity called catenation capacity, that it is maximum catenation capacity is 8. That means it can combine only up to 8 elements, 1 2 3 4 5 6 7 8. Okay, so maximum capability that it can combine with silicon with another silicon only 8. So further it is not having the capacity because of the higher size. Down the group, the catenation capacity is decreases. See, all the properties what we have discussed in the periodic classification, generally it is applicable for all. That is how the metallic character, how the ionization enthalpy, how the electron gain enthalpy, electronegativity, all these things. It is down the group what will happen, to left to right what will happen, all these things we have discussed in general in the periodic classification. That properties, it is applicable for all the properties. That's why we are not discussing here. In this case, only some properties we are discussing. So this is in catenation capacity. In the case of carbon and the silicon, it is very more for the carbon and very decreasing down the group, right? So because of the increase in the size. Now if we move to this one, that is I told you, that is this belongs to carbon, silicon, germanium, tin and lead. This is a carbon family. Okay, now this some of the important, that's in silicon, it is used in the semiconductor, for the preparation of semiconductor. Pure silicon, it is called as in quartz, right? Silicon with the carbon, it is called as in silicon carbide, and it is silicon carbide, it is useful in the preparation of the solar cell. Okay, that is an electrical energy formation for the chemicals. In the solar energy, there is light energy is converted to electrical energy by using these cells. That is in light energy, the sunlight energy, it is going to be converted into electrical energy to run the world. And now silicon nitrate with jute, it is useful. It is also some of the constituent. It is a bulletproof jackets. And the mixture of one is tin, lead, it is useful in the preparation of fuses. Tin, lead with the silicon, it is used in the electric fuse wire, and also it is in the soldering, right? The next, carbon dioxide, that is one of the oxides of this carbon family. Carbon dioxide, it is useful in the manufacturing of washing soda. Hope you remember the washing soda formula, that is Na2CO3.10H2O, sodium carbonate decahydrate, and it is useful. Carbon dioxide, it is useful for the preparation of sodium carbonate by Solvay ammonia process. Carbon dioxide is the best fire extinguisher. Okay, best fire extinguisher, whether you are using by the sodium carbonate or with the hydrochloric acid, sulfuric acid. So this is best fire extinguisher. It will put out the fire, and it is useful for the preparation of urea. You know that the urea, it is called, the formula, general formula for urea is NH2 C double bond O NH2, right? So carbon dioxide, it is derived, that is an urea, carbon dioxide, it is converted to carbon monoxide. In this called generally it is called as an what do you call, carbamide. The urea, it is called as an, chemically it is called as an carbamide. Now in this case, the dry carbon dioxide, if you are going to be convert this carbon dioxide into a solid one, that is called as an dry ice. That is carbon dioxide, if you make it is if you make to involve in sublimation, this will be converted, this is a gas now. Okay, it will be converted to, once if it is sublimed, then it will be converted into, it is a gas, here it is a solid. Okay, so carbon dioxide basically it exists in the form of a gas, and sublimation is a process where we are going to be convert the solids directly into gas, or the gases is directly converted into solid, no intermediate stage called liquid. So the conversion of direct solid to gas or gases to liquid without involvement of, without changing into the liquid state, that is called sublimation. So once if you take the carbon dioxide gas and if it is applied for the sublimation can be done only under high pressure and low temperatures. Already I told you, at very high temperatures, very high pressure, in the case of behavior of gases we have discussed this one, at very high pressure, around about 10,000 pascals of pressure, and at very low temperature, particularly this temperature is minus 273 degrees centigrade, the gases, it loses the property. So slowly it will try to convert into liquid. So it will convert into liquids at this temperature and at this high pressure. So gases, if you are going to be provide this condition, carbon dioxide, if you provide this condition, what will happen? This carbon dioxide will be converted into solid. That solid carbon dioxide, it is called as a dry gas. Solid dry gas, it is nothing but solid carbon dioxide. How you are preparing? By the process called sublimation. Solid carbon dioxide, it is not directly, it will not convert into liquid, instead directly it will convert into vapors. Okay. The next one, silicate, that is an SiO2, silicon dioxide or silicate, commonly called it is an silica or silicate. Okay. There is an pure one, it is an quartz, it is called as an quartz, and it is used in a material called piezo electrical material, which are used in the case of the watches, and silica gel which are using from the silicate, it is useful as a adsorbent in the case of chromatography. It is a process of separation of different types of liquids based on their adsorption coefficient. Here the silica gel, it acts as an inert medium, that it is not going to be react with any other chemicals. So that this, if you are going to be provide an inert medium, for example I'll draw roughly. So this is an column chromatography. Okay, so now this silica, consider this as silica gel. Okay, this is silica gel. Now this silica gel is an inert medium. I am filling this silica gel completely to this tube, this column. Okay, completely I have filled. Now this I am going to be, on this one I need to separate my components called A and B. I'll place my components called A and B, right? So after that I'll add some solvent to this one, right? First I have taken column, I filled with all the column with the inert medium called silica, right? Now I am going to separate my sample called AB, right? This is my sample what I want to separate, that is I want to separate A from B. Okay, after that I am adding some solvent. What will happen? Depending upon the adsorption coefficient, A may be up to come here, B may be here. After that, that means A can be separated, B can be separated first, because it is having the less adsorption capacity. If it is having the more adsorption capacity, it will not move very fast. So which is having the less adsorption capacity, it will migrate very fast and it can be separated by the process called adsorption chromatography. So silica gel here we are using for providing an inert medium, right? So it acts as an adsorbent in the inert it acts as an adsorbent in the chromatography for the separation of different types of liquids which is having the difference in their adsorption capacity. So that is the information regarding your what is called carbon family. Thank you.